Hello class, and welcome to today's algebra lesson, which is about transformations of exponential functions. By the end of today's lesson, you will be able to identify the ways that exponential functions have been moved and reshaped on a coordinate plane. So our first thing we're going to look at is the translations. These are the left, right, up, and down movements of a function. So our most basic function is going to be a number to the power of x. And the transformation of translations occurs by adding and subtracting numbers to that basic function. If you are subtracting a number in the exponent portion, that is going to move your function that many units to the right. So if you have a minus number, so x minus 4, for example, would move it 4 units right. If that number in the exponent is addition, that would indicate that that function is moving left. If the addition or subtraction occurs after the exponent, so at the very end of the function, that is going to indicate to you the up and down movements on the graph. If it is addition after the exponent, that is going to indicate it's moving k units up, and if it is subtraction, it is moving down. So, for example, my basic function for this one is 5 to the x power. The transformation is 5 to the x plus 3 minus 7. So first I start by looking in that exponent. Since I have a positive 3, that is going to indicate that my function is moving left 3 units. So it's going to be translated, slid across the graph 3 units to the left. This negative 7 is going to tell me that the whole function is being pushed down the graph by 7 units. So the whole graph has been slid 3 units to the left and 7 units down. Go ahead and try this one on your own. In this case, I've got a subtracting 8 in the exponent, which indicates it moves 8 units right, and adding 4 at the end means that it's moving 4 units up. The other two types of transformations that we're looking at are reflection and dilation. Again, our most basic function is b to the x power. Reflection and dilation occur when there is multiplication happening in the problem. If there is a multiplication at the very front, so there is another number in front of your base, and that number is negative, that is a vertical reflection. So what that means is the basic exponential function moves up as it goes from left to right. If it is a vertical reflection, that means that it is going to move down from left to right. If there is a negative up in the exponent, that is going to indicate to us a horizontal reflection. So once again, the original graph from left to right is going up. The horizontal reflection would mean that from left to right, it is going down, but in a different way. So we have our vertical reflection and our horizontal reflection. Then, going back to this number in front, if that a value, if the number in front of that function is greater than 1, it means there is a vertical stretch occurring. So it means the graph would be taller than the original function. If it's between 0 and 1, so a decimal or a fraction between 0 and 1, then that function would be getting flatter. It would be squished down compared to the original slope that it had. On the flip side of that, if your multiplication occurs in the exponent, then it's a horizontal transformation. So if it is greater than 1 in the exponent, your graph is going to be getting narrower. So it is going to be compressing horizontally. And if it's that decimal, smaller than 1, up in the exponent, then that means it is going to be getting wider. So it is going to be squishing down, which means it is spread out horizontally. So when I look at an example here, my original function, f of x, is equal to 7 to the x power, is being transformed to negative 5 times 7 to the 2x power. So I start, because there is a negative in front, that is going to tell me that there is a vertical reflection. So it flips up and down on that graph. That's what that negative indicates. Then I have a 5 in front as my A value. That 5, because it is greater than 1, is going to tell me that it is a vertical stretch or that my graph is getting taller. I will accept if you write vertical stretch. I will accept if you write taller. The last piece in the back, I have that bonus multiplication of 2 in my exponent. Because of that, that means that my graph is going to be getting narrower. You could also write horizontal stretch, or excuse me, not horizontal stretch, horizontal compression to indicate that 2. So again, the negative is the vertical reflection, the 5 makes it taller, and the 2 makes it narrower than the original graph. Another example here, starting with 3/4 to the x power, it has now been transformed to 7/8 times 3/4 to the negative 0.3 power. So I start by looking in front. That 7/8 is going to tell me that it is a vertical compression, so my graph is getting flatter. Again, you could write vertical compression or flatter. When I hop up to the exponent, I now have a negative in that exponent, so that is going to tell me that it is a horizontal reflection. So that means we have flipped it from left to right. So I've got a horizontal reflection. That last piece up in the exponent, which is a negative, that 0.3, we already dealt with the negative, is going to tell me that I have a horizontal stretch or that my graph is getting wider. So it is getting flatter from the front and wider from that exponent. Go ahead and try this one on your own. So that negative in the front makes it a vertical reflection. That positive 2/3, so this 2/3 right here, is what makes it a vertical compression, or you could indicate that your graph is flatter. So either way, vertical compression or flatter. The last piece is that 1.8 up in the exponent, which is going to indicate to you that you have a horizontal compression or that your graph is getting narrower than it originally was. We also can put this. For the final piece, we are putting all of this together, the translations, reflections, and dilations. So my original function was 6 to the x exponent, and then I have this transformed function down here. So I want to go through each step in order. The first piece I have is this negative out front. That negative is going to indicate to me that I have a vertical reflection. There is no other number out front, so I don't have to worry about vertical stretch or compression. Then I jump up to my exponent. There is no negative there, so there is no horizontal reflection, but I have this 2 being multiplied. So that 2 in the exponent tells me that there is a horizontal compression going on in my function. Again, you could write that as narrower. Then I have adding and subtracting going on. The subtracting 3 in my exponent is going to tell me that I am moving right 3 units because it is a negative h value in that exponent. And then the last piece that we have going on here is a subtracting 12 at the very end, which means that we are moving down 12 units from where the function originally was. Once again, another example of this, starting with a basic 2/3 to the x power. I need to go through and look at my different transformations. This 6 in the front is going to tell me that I have a vertical stretch. My graph is getting taller. Then I have that negative up in my exponent, which is going to indicate to me that I have a horizontal reflection. So my graph has flipped from left to right. Then I have an multiplication in my exponent by 0.4. So that's going to indicate to me that I have a horizontal stretch occurring. So my graph is getting wider. And then the last piece is we have a plus 8 at the end, and that is going to indicate to me that I have moved my graph up 8 units. So again, multiple transformations going on in this function. Go ahead and try this one on your own. So my negative in the front indicates to me that I have a vertical reflection. 5/4 is greater than 1, so even though it's a fraction, it's above 1, so it gives you that vertical stretch. Then this plus 6 indicates that it is moving 6 units left, and the subtracting 14 tells me that I am moving 14 units down. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.